Okay, in this part we will be evaluating polynomials. We have just defined polynomials, their degrees, and so forth. So how do we evaluate polynomials? Well, first of all, our polynomials, we can say that each equation which I will give you will define a function. So let me give you some functions. So this is a function f x equals 6x plus 4. Defines a function because each input x value, so if I input a value here for the x, I would say for example, if I was to say the number 2 replaces the x, then that would be 2 times 6, which would give us 12, plus 4, which would then give us 16. So this is a polynomial, has two terms, its degree is 1. So we can say that since the right hand side of each question of this equation is a polynomial, these functions are called polynomial functions because it is a polynomial of two terms. What's the degree? Degree 1. Okay, since the right hand side of each of this question is a polynomial, these functions are called polynomial functions. So these are known as polynomial functions. So let's see how we can break this up. This piece here, this polynomial has two terms. Its degree is 1. Okay, let's go to our next function. F x equals 3x squared plus 4x minus 5. Now be careful, we can put here z, x, h, x, it doesn't make no difference. Alright, write this down. This is a polynomial of degree 2. 3 terms, trinomial. So this polynomial has 3 terms. Its degree is 2 because that's the highest power of the variable. Let's go with the next one. Each x, and I'll use a different letter, negative x cubed plus x squared minus 2x plus 3. Alright, this one here is a polynomial because it has 4 terms. Its degree is 3. Okay, to evaluate a polynomial function for a specific value, we will replace the variable in the defining equation with the input value. So if we want to evaluate any one of these polynomials here, we will take the value for the variable and input it there, and so we will get a value as the end product. Then we simplify the resulting expression to find the output. For example, suppose we wish to evaluate the polynomial, this one here, the first one. So let's start with the first one, which is the simplest one to work with for right now. Let's working for right now. So if I have the function f x equals 6x plus 4, and I tell you to evaluate this polynomial for x equals 1 or x equals 2, x equals 90, doesn't make no difference, then f1, okay, represents the value of f x equals 6x plus 4 when x equals 1. So this is what you're going to do to solve this problem here. You're going to say now f x, write it down this way every time, and I'm going to say now I want to replace x by 1 depending what value they tell you. So you're going to say 6 times 1, you put your brackets, you continue writing the rest. Okay, let me put this in red instead so you can see what we are inputting different there. Alright, and then we say equals, well, 6 times 1 will give us 6 plus 4, which then gives us 10. So thus, or therefore, f1 equals 10. That simply means that this function has a value of 10 when x equals 1. Okay, so let me write what I did here as a rules. This is the given function. Substitute, which I did here, 1 for x. The number 1 is inputted. Let me put it here. Is input. Perform the multiplication, then perform the addition, giving us 10 is the output. Not to say 10 will always be the output for all of these problems here. So this is how you evaluate polynomials. We'll simply substitute the variable by a number or a value that they give you into the question, no matter which polynomial it is. If it's this one, just substitute it there and you'll follow the same procedures.